Hello and welcome to my video on section 6.3. This is going to be taking a look at trinomials in the form ax squared plus bx plus c, but in this case we're going to have something a little special going on here. This is not a general factorization of this polynomial, which we won't see until we get to the next section in section 6.4, where we'll talk about how to factor this trinomial in general. But this is basically a special case. So please be sure to take some time and review the reading for other definitions and important information and the specific pages that I asked you to review in the textbook that is located in the guided lessons for this section. Anyways, let's take a look at a couple of cases here where we have the sum and the difference of two binomials. And let's just notice that a and b could be anything. And if it helps you, you can replace the a and b with a square and a triangle, where we can replace these with numbers, where we can replace these with variables, or where we can replace these with variables and numbers. So it's just kind of these open cases. So we kind of got to bring our mind outside the box when we take a look at these things as a and b, and hopefully we're starting to get used to math with letters as well. So let's just note that by definition that a plus b quantity squared is basically a plus b times a plus b. And again, using the foiling method, note that we do the first. And when we do the first terms, we get a times a, which is a squared. Okay. And notice that when we do the, let's see, FOIL F outside terms, we get a times b. And then when we do the inside terms, we get b times a, which is the same as ab plus. And then when we do the last terms, it's b squared. And notice that this reduces down to a squared plus 2ab plus b squared. So the idea is to note that, notice when we're given this, what we're going to do at the end of the day is to rewrite it like this. That's what we're heading for. And notice that this thing here is a minus b times a minus b. And again, using the FOIL method, we have the first terms, which is a squared. And then O is the outside term, so we get a times a minus b, so we get minus ab. And then we do the inside term, so we get negative b times a, which is also minus ab. Okay, and now we get negative b times negative b, which is plus b squared. And notice that at the end of the day, we end up with a squared minus 2ab plus b squared. And again, we're going to be given this thing as noted right here, and we want to rewrite it in this way. Okay, so that's kind of the goal of what we're doing now, is given this one of these trinomials, either this one or this one, okay, we are going to rewrite as either this way or this way. And here's something I also want to key in on, is notice that we have everything here is involving pluses, but notice that this middle term right here has a subtraction. And notice that this guy here is positive, so it has to be in this form. So let's take a look at some examples to kind of get an idea what's going on. So here I have x squared plus 22x plus 121. All right, so notice, to come back up here, is that if I take a look first at the leading term here and the ending term here, the question is this written as something squared, and is this written as something squared? And notice that I can rewrite this as x squared, so this is this guy right here. And the 121, let's just note that this is 11 and square it. So notice I kind of have this A is going to represent X, B is represented by 11, and let's just note then the question that we have to ask, since we have pluses right here, is notice this middle term right here. This middle term right here and right here is 2 times AB. So let's just ask, is this middle term right here, does that middle term, can I rewrite, is this written in terms of 2 times X times 11? And notice that when I do this product, I get 2 times 11 is 22x. And here we can see that this is the case. So when I see something like this, when I have this, and I see that the middle term is 2 times the product of A and B, again, let's just note, let me write here, A is X, B is 11. So the question is that middle term 2 times this times this? All right, so then I end up with X plus 11 quantity squared, so I'll just write it in that form right there. Okay, let's take a look at another example. So here we get X squared minus 12X plus 36. So again, I'm just asking myself, is the first term, this X squared term, can I rewrite this as something? And notice that this is just X squared. And notice that 36 is written as 6 squared. So now we have A is equal to X, B is equal to 6. So now our question is, do we have that middle term as 2 times A times B, which is 2 times X times 6, which is 12X. And notice that this 12X is not the same as this 12X because we have a minus right here. So now the question is, well, how do we deal with that? Well, let's just also note that 36 is not just 6 squared, but it is also a negative 6 quantity squared. All right, so now the question is, when we have that minus, notice that when we have the minus here and the plus here, maybe we should consider a minus b. So now this becomes this way, okay? So we know that's wrong. So now we have 2x negative 6, and can we agree that this is minus 12x, which is the same there? So that being the case, this factors to x minus 6 quantity squared. Okay, so we have the difference of two, what we call the difference of two squares, and here we have the sum of two squares. All right. Now let's take it up to an example where the leading coefficient is not 1, so I'm looking at 16a squared minus 24a plus 9. So again, in this case, notice the leading coefficient for the a term is not 1, as they were in the previous two examples, but still we play the same game. And again, let's just notice that that is a negative. So we got to be careful, like we talked in our previous example. So let's just note that 16a squared, I can write this as 4a quantity squared. And now can we rewrite something that is a squared? And notice we get 3, but since we have our negative, notice we might want to consider a negative 3 squared. So again, that gives us this guy, and that gives us this one. All right, so now the question is do we get our middle term, right? Is our middle term twice the product of a and b? So let's just double check. So here we get 2 times 4a times a negative 3. So 2 times 4 is 8 times negative 3 is minus 24a, and that checks out. So then at the end of the day, notice that we're going to get this minus this. So 4a minus 3 squared. So again, I didn't do this with the other two. Let's just go ahead and take a second and do this real quick. But notice that this is 4a minus 3 times 4a minus 3. And again, employing the FOIL method, we get 4a times 4a, which is 16a squared. And then we get 4a times negative 3, which is minus 12a. And then negative 3 times 4a, which is minus 12a. And then negative 3 times negative 3, which is 9. So here we get 16a squared plus 24a plus 9, which is what we started with. And that's exactly what we wanted. So again, just to make note, we can go through and double check our work. So let's do another one where the leading coefficient is not 1. So I'm looking at 9y squared plus 48y plus 64. So again, we see that everything's in order. And now we take a look at our first term here, and I can see that this can be written as 3y squared. And I can see that 64 is 8 times 8. And it is also negative 8 times a negative 8. But since we have a plus sign, we don't need the negatives here. So we can rewrite this as 8 squared. So again, we have to do our check for the middle term check. So we have 2 times 3y times 8, okay, which we get 6y times 8, and 8 times 6 is still 48, and we get our y. So that checks out. So notice that now we can write this in its factored form as 3y plus 8, and this whole thing is quantity squared. All right, so far we're doing really pretty good. Okay, so here's another example. I think I'll just throw this one up, and for those of you that would like to bring your answer to class, oh no, this one here is a little bit different. So let's take a look at, scratch what I was going to say, 16p to the 4th minus 88p cubed plus 121p squared. Okay, so notice that before we were looking at things in the form of ax squared plus bx plus c, and I think we can all agree that this does not appear to be that way. So again, what I'd like to do is to stop for a moment, okay, to stop for a moment and see if there's anything that we can pull out. That is there a greatest common factor that we can pull out of everything? So one of the things that we can do, let's take a look at numbers. So we got an we got an odd number here. We know that 16 is 4 times 4, or 2 times 2 times 2, 88. But 121, the only thing I can come up with 121, now let's see, 121, is that divisible by 3? Let's see, 4, we get 12, 1, no, that's a 0, so that's not going to work. So the odd number here, no even numbers will divide into 121 since it is odd. So there's nothing to pull out from that one. So as far as the numbers are concerned, we don't really have to worry about the numbers. But notice on the letters, I got a p to the 4th, p cubed, and a p squared. So let's just note that I can pull out a greatest common factor of p squared. And that leaves me with a 16p squared minus 88p plus 121. Okay, so again, looking at this form here, again, one of the things I can do is go back and repeat this process here. So we have 16p squared, and let's just note that that is 4p quantity squared, and the 121, well, 121 we know is 11 squared, and we also know that it's minus 11 squared. And since we have our subtraction right here, we know we're going to choose the negative 11 quantity squared. So now as our last piece of the puzzle, we have to take 2 times 4p times minus 11, okay, which is 8p times minus 11, which is negative 88p. And notice that that is exactly the same as here. So this thing factors, so we get our p squared comes down. So now we get our 4p minus 11 quantity squared. So this thing is completely factored. All right, so I have one more example. This is the last example, and this one involves two variables. So 49x squared minus 70xy plus 25y squared. So again, as I take a look through these numbers, I'm not really seeing anything in the numbers that I can pull out. We do have a 7 here and a 7 here, but that's about it. I don't get the 7 with the 25, so there's no greatest common factor. Look at the variables. I got x squared, I got an xy, and I got a y squared, so there's nothing I can pull out regarding the x's and the y's. That is within the 3 terms. So I'll go to my next step and then take a look at this first one here, our first term, and note that I can write that as 7x quantity squared. And notice that the 25 can be rewritten as 25y quantity, as 5y quantity squared, but we have a negative here, so we're going to have to throw in our negative there. Okay. All right. So here we have our candidate. So now we have to do our middle term check. So here's a way of taking a look at that. Middle term check. So we go 2 times 7x times a negative 5y. Okay, so now I get 14x times a negative 5y. And again, 5 times 4 is 20. So 5, 6, 7. If you want, you can go ahead and throw your calculator in. And here we get an x and a y. So notice that this is exactly the same as, let's not forget our y here. So we get that right there. So that means that this factorization then comes down to nothing more than 7x minus 5y quantity squared. Okay? All right, and let's just recall that if you do have one of these trinomials and any part of this process, you know, this doesn't work, either A, it's prime, or B, we have to try a different technique. So we have to exhaust all the techniques right now before we can identify something that's in the form, or if something is prime. All right, so in our next video, we'll kind of come to a generalization of how to do this. Some people call this a different method, but I'll talk about that in the next section. All right, I hope this video helps out, and I will see you guys in class. Thanks.